All right, graphs and functions. Yeah. I think there are some days. All right. So our objectives here are to identify the graph of a function and obtain information from or about the graph of the function. Information being your attributes, your intercepts, your domain, range, your max, min, all those fun things to describe a function. Okay. So first we're going to talk about identify the graph of a function. So to know that you're dealing with a function, that is using the vertical line test. Okay? If I'm dealing with a function, it will pass the vertical line test. What does that mean? It means that as I navigate along that function, I will only touch one point at a time, right? So for example, I have these two graphs here, and I want to know if they are functions. I would then take a straight edge of some sort and travel along the graph. If I only touch one point at a time, they are functions. So A and B are examples of functions. To be very specific, this is the quadratic. This is a quadratic, and this is a question so far. Do you feel comfortable identifying whether a graph is a function or not? Awesome. Okay. Now, here are two examples of non-function. And why are they not function? It touches the x value touches two. I can't talk. The x value repeats. That's what I was trying to get at. The x value is repeated. And so therefore, this is not a function. These are just graphs of rows. Okay. Still good? Cool. Next, our goal is to obtain information. When we say obtain information, we want to know as much as we can about the graph. We should be able to describe all the different attributes of the graph. So the first task that you should be able to do from a graph at this point is to be able to identify values. So if I'm looking for f of 1, you should be able to look at a graph, go to x equals 1, and tell me the answer. And what is it? 2. So I go to 1 and I get 2. If you have f of 0, that means I'm going to go to x equals 0. And what do I get? 0. If you have f of 4, that means I'm going to go to x equals 4. And what do I get? Negative 3. Okay? Questions about identifying values in a graph. We're good? All right. Domain. Your domain is asking what's happening as the graph goes towards negative infinity. And then what's happening as the graph goes towards positive infinity, right? So from left to right, what's taking place? When I look at the furthest left this graph goes, where does it stop at? Negative 4. When I look at the furthest right that this graph goes, where does it stop at? Positive 4. Okay, at each one they are defined, right? They are defined. We use bracket. If they were not defined, we would use parentheses. Okay, so this is telling us that our x is between negative 4 and positive 4. Agree? All right. Our range. This feels like a review, right? I hope so. Our range is from bottom to top, right? So what's happening from the bottom to the top of the graph? So when we look at our range, the lowest that it goes to is negative 3, and the highest that it goes to is 2. Are they both have values? Yes. So we use bracket. So this is telling me that my y exists between negative 3 and positive 2. Questions about domain and range? Okay, we're going to keep it pushing. All right, intercepts. When it says list the intercepts, that means you're listing your y's and your x-intercepts. Okay. So when I look at here, your x-intercepts are where it crosses the x-axis, and your y-intercepts are where it crosses the y-axis. In total, how many intercepts does the function have? 3. 1, 2, 3. You see that? Yes, but it just asks for intercepts with all of them. So we would have -3, 0. We have 0, 0, and we have 3, 0. Those are my intercepts. How do we feel? Still with me? All right. Next, it says, how many times does the line y equals -1 intersect the graph? And when it's asking about intersecting of the graph, y equals -1 is a horizontal line. So if you have a horizontal line going through -1, it's wanting to know where does it intersect the graph. So going through -1, how many times would I intersect the graph? 3. So the answer is simply 3. It would intersect 3 times. Okay. The next thing, this right here, when it says when you're evaluating, and you're given the y, that means you're looking for the x. So it's giving you the y because f of x just means y, right? So it's asking for what x values will give you -3. So you're looking for x values that will equal -3. So if I go to -3 on this axis, where is it? The only x value that gives you -3 is +4. So the answer would be 4. You're going backwards. So you're given the dependent and you need to find the independent. Okay. The last way that you need to be able to analyze a graph is using inequalities. So this is asking for when is the function greater than 0. If f of x again is y, so this is saying when are the y values greater than? When are the y values greater than 0? Which means when are they positive? What type of y value is 0? Positive y value. So when do you get positive values? Well, it's in intervals, right? I'm greater than 0 from -4 to -2. See that? I'm above the x-axis. So here is a piece when I'm greater than 0. So I would write it as from -4 to -2 is one of my answers. Okay. Where else am I greater than 0? Well, I'm also greater than 0 from 0 to 3. So the other part of my answer would be from 0 to 3. Notice that they are parentheses, not brackets, because does it say equal to 0? No, it says when is it greater than 0. So this is telling me if I want values that are greater than 0, I need to look for values that are for x values between -4 and -2, or x values between 0 and 3. That's when I will find values greater than 0. Okay. Questions so far? All right, we're going to keep analyzing graphs. So what if you're not given a graph, but you're just given the function? Well, that's okay. That means that you're going to just use your knowledge of what the graph would look like, right? And that goes back to understanding what the parent function would be. Okay. So what would be the parent function? X plus 3 over x plus 4. It would be 1 over x. It would be a rational, right? Because it's a rational, I know that there's a restriction caused by the denominator. There's a restriction on my domain by the denominator. I know that x plus 4 cannot equal 0. What value of x would make it equal to 0? -4. So x cannot equal -4. So when I'm writing my domain, if I'm writing it in set notation, braces x such that x doesn't equal -4. That's an option. If I'm writing it in interval, that's saying that my graph is going from -infinity to -4. However, once I get to -4, I have to stop and then resume. So either one of these are acceptable ways of describing the domain of this function. Okay. When it asks you is a point on the graph given the equation, what that means is you're going to substitute in for x, substitute in for y, and see if they make true statements. So if I substitute in for x and y, is there going to be a true statement? So we have, so if we have 3, 4 equal to 1 plus 3 over 1 plus 4, let's see if this is true. I have 3 over 4. I have 4 over 5. Is this a true statement? No, it is false. So what does that mean? Is this a point on the graph? No. It's just verifying. It's just a verification. Do you feel comfortable with these two? Questions, comments, concerns? We're still good? Okay. All right. So still using the same function. If x equals 2, what is f of x? When it's telling me a domain value, that's just function notation. So I'm looking for f of 2. F of 2 means wherever there is an x, I'm substituting in a 2. So we have 2 plus 3 over 2 plus 4, which gives me 5 over 6. So my answer is, what is the value? Got it. What is the point? So when I'm writing it as a point, it becomes 2, 5, 6. So f of 2 equals 5 over 6. What is the point? The point is 2, 5, 6. Okay. The difference between C and D is that C gives us our X. D gives us our Y. Do we see that? So it's giving us that Y equals 4. So this time we're substituting in for Y, not for X. So we know that f of x equals 4, which equals x plus 3 over x plus 4. And now we're going to do everything to get x by itself. So the first thing we have to do is get x out of the denominator. So we're going to multiply both sides by x plus 4, which leads me to 4 times x plus 4 equals x plus 3. What's the next thing I'm going to do? I'm going to distribute the 4. That gives me 4x plus 16 equals x plus 3. I'm going to subtract 16 and subtract x. Still with me? So we have minus x minus 16, and we're left with 3x equals negative 13. And our last step is to divide by 3. So x equals negative 13 divided by 3. If you were to do this by graphing in the calculator, would you get the exact value? No, it will give you a decimal approximation. So unless it's asking for an approximation, that means that you're solving it by hand to get the exact value. Okay? Questions, comments, concerns? Was it terrible? All right. The last thing is what are the x-intercepts of the graph, if there are any. For x-intercepts, that means you're substituting in y equals 0. So when you're looking for x-intercepts, that means you have f of x equals 0. So I'm looking for f of x equals 0. So x plus 3 over x plus 4. So in this case, again, to get x out of the denominator, we would multiply both sides by x plus 4. But anything times 0 is going to be what? 0. So I'm going to be left with, if I have 0 x plus 4 equals x plus 3, that's just going to leave me with 0 equals x plus 3. So what is x? X equals -3. So x equals 3. So my x-intercept is at -3, comma 0. How do you feel about algebraically finding the x-intercept? It means, again, you're doing what with the whole function? You're setting the function equal to 0 if you're looking for your x-intercept. All right. Okay. So here is a word problem giving you a reason to solve and find things. So here it says the average cost C per drone of a manufacturing X drones per day is given by the function. And it wants us to determine the average cost of manufacturing 10 drones, 20 drones, and 30 drones. Okay. So if I'm just calculating costs, this is, even though it's a word problem, it just means that function-wise, I'm looking for C of 10, right? I'm looking for C of 20. I'm looking for C of 30. It may be a long drawn-out equation, but that is all I'm doing. Does that make sense? Okay, so that would fall under a calculator problem because those numbers are kind of large. The main thing is that you just is making sure that you understand what you're calculating. So we talked about yesterday that there's more than one way of doing this. If I have 3 values that I'm trying to find, would I want to have to type those 3 values 3 times? No, I wouldn't. So in this case, I would utilize my y equals and put the equation 0.7x squared minus 45x plus 1,320 and 2/10 plus, I'm gonna have my fraction 1,000 divided by, thank you, 10,000 divided by x. Okay, so I've inputted. And again, we talked about if I'm looking for specific values, I can go to the table. And when I go to the table, I'm going to put it on second window and go from auto to ask. And this allows me to find the values that I need. So I need 10. I need 20. And I need 30. So there are my values. You could just as easy scroll down all the way to 30 if that makes your heart happy. Why would I tell you not to do it the long way? You can't say I didn't show you the shorter way. Get what I'm saying? Okay. It was 2 buttons. Second window. It was second window. So we have 1,940 and 2/10. We have 1,200 and 2/10. And we have 933 and 53. Okay. The key thing here also is that if it wants multiple places, you just arrow over and you can see all the full value if there are additional decimals. Questions so far? Easy peasy? All right. So now it says to graph the function. Well, I've already set myself up for success, right? I've already put it into the y equals. So if I want to graph this, it wants to know what restrictions do I have? So I want to graph only from 0 to 60. So if I'm setting a restriction, that means that I'm changing the values of my domain. So right now, my domain goes from -10 to +10, but I need to change it. To change it, all I'm doing is clicking window, and I'm starting from 0 and working my way to 60. And I'm going to hit graph, and I'm going to see, can I see anything? I'm like, oh, that didn't help. So I've now narrowed down my domain, but I need to also modify my range. So modifying my range, I don't want to count by tens. How low should I go on my range? Let's say from 0, based on our numbers that we had, they were pretty large, right? So what's our largest number? 1900? So let's say 0 to 2000. And we'll count by 100. Let's see what that looks like. Oh, I see some action. See what's taking place here. So now I can see what's happening with this graph. And I can describe what happens to the graph. The graph decreases and then it starts to increase. Do we see the change? So it says here, create a table which value of X minimize the average cost. So at what point did I get to my lowest value on this right here? So I'm looking for that minimum value. The problem here is that normally you would think it would just tell you to go to 3 and click on minimum. So if I'm doing that, the problem is that the graph, and it feels that the way it's programmed, in order to find a minimum value, you have to change signs. And the thing is, you're not going to necessarily change signs here. So you just got to move it as far as to the left you can go and as far as to the right you can go, and it should find a minimum value for you. Okay, so here to minimize the cost, my average cost, looking at what I have, it would have to be roughly how many drones would have to be sold? 37.3, so roughly 37. $37 drones. Okay, if you were to do it the way by looking at the table, that means you would be scrolling until you see the smallest value between 0 and 60. Which you can, but if you can use the graph, why not use the graph? Okay. Make sense? All right, questions so far about calculator usage and analyzing functions? None? Awesome. That's it. That is 3.2.